Hello everyone and welcome to this special forum which is entitled Acts of Magis, Ateneans at the Forefront of a Pandemic. The special forum is co-sponsored or co-organized by the University Research Council and the Ateneo Research Institute of Science and Engineering. We are going to present to you experts in their own field, professors from the Loyola schools who have carved a name for themselves because of what they have done in society to respond to the needs. They're not just armchair researchers, they're also passionate individuals that want to do whatever it is for the common good. So this special forum is our way of telling our public that there is something that, not just that there's something that we're doing, but that we can harvest something positive from what is negative in our society. So I'd like to welcome you to this, and I hope that you will get to go home after the presentations, taking away with you a lot more hope and courage as we face the turmoils in our society. So welcome again and enjoy the presentations. Thank you.
Good afternoon, everyone. This is Acts of Magis, Ateneans at the forefront of a pandemic. Today, we'll have Dr. Toby Dayrit to share his research and works. This is the second episode of Acts of Magis. Last week, we had Dr. Rina Estuar with Faster. And again, we'd like to thank the people who put together Acts of Magis, Ateneans at the forefront of a pandemic. They themselves, in a sense, are doing this at the forefront. And specifically, we'd like to thank the University Research Council, or URC, and the Ateneo Research Institute of Science and Engineering, or ARISE. So our guest this afternoon, as mentioned, is Doc Toby, and if you could see him in your screen, he's wearing a very lively shirt. Good afternoon, Doc Toby.
Hi, good afternoon, Chris. Good everyone.
All right, sir. Without giving us your address, where are you located currently?
I'm in Quezon City.
You're in Quezon City, all right. So it's quite a hot spot, no, for the COVID cases.
Yes, I'm afraid so.
Yeah, and while we know I think it's an open secret that you are a senior citizen. It's nice to see that you are well and strong.
Well, my wife takes care of me, feeds me very well.
And apart, yeah, no. So hello to Mrs. Dayrit, right? Thank you for taking care of Doc Toby. And I'm sure another reason why you're in tip-top shape is, of course, your coconut concoctions. Tama po ba?
Oh, yeah. Yeah, tama. Dapat na tayo ay kumain ng coconut. So
Ayan.
every morning.
All right, all right. That makes me actually want to grab some coconut juice right now, no? But before I do so, so again, ladies and gentlemen, for the second session of Acts of Magis, Ateneans at the forefront of a pandemic, we have with us Dr. Toby Dayrit.
Thank you. So let me get set up. Okay. Well, so good afternoon to everyone. And I'm very honored and pleased to be given this opportunity to talk to you about the work we've been doing on coconut oil as one of the possible measures against this coronavirus. Coconut oil is not what you would call a quote-unquote high-tech cure, like drugs and vaccines, but it brings out the power of simple solutions, and it is a science to back it up. First, I would like to thank our sponsors, the Acts of Magis webinar, Dr. Marlo Vilches, Vice President for the Leon Schools, the University Research Council under June Aguilar, the Ateneo Research Institute for Science and Engineering under Dr. Len Espiritu, the Office of Research and Creative Work under Dr. Ninette de las Peñas, University Marketing and Communications Office under Ms. Matek Villanueva, the IT Resource Management Office under Sandra Lavenia, and of course our host, Chris Castillo. So how did this all start out? As early as mid-January 2020, it was becoming clear that this novel coronavirus, which was breaking out in Wuhan, China, was very dangerous. It was still called 2019-nCoV at that time. On January 31, Dr. Mary Newport and I co-authored a review of the available scientific literature on the potential of coconut oil and its derivatives as effective and safe antiviral agents against the novel coronavirus. Dr. Newport is an American pediatrician who is involved with research on Alzheimer's disease and coconut oil. So we posted this article on social media as well as on the Ateneo website, where it attracted a lot of attention. It is important to stress that that there was a lot of science behind this paper. Fortunately, the Philippine Council for Health Research and Development of the DOST saw enough merit in this hypothesis to fund an in vitro study together with Dr. Erwin Enriquez and Dr. Chris Lopez. And so that's how it all began. So here's my outline. I will start with the virus, that's SARS-CoV-2, the disease, which is known as COVID-19, the reason why hand washing works, and the theory why coconut oil works as an antiviral. Finally, some thoughts on how we can survive COVID-19 and beyond. By now, with all the information overload, we're all probably aware of very well informed regarding this novel coronavirus. In this short section, I will just highlight the important features of this virus, SARS-CoV-2. So the coronavirus is a virus family, one of 71 currently known virus families. And there are 4 major groups of coronavirus. SARS-CoV-2 belongs to the beta coronavirus group. It is also useful to note, or important to note, that coronavirus and the influenza virus belong to different families. So saying that the coronavirus is just like the influenza is probably not quite correct. This is a cartoon image of this virus. And I would like to highlight the following features. First, it is a spherical object, a nanoparticle, measuring between 80 to 120 nanometers. So it is about 100 times smaller than an E. coli bacteria. Second, this coronavirus has 4 structural proteins. The protein that is of most interest to us here is the spike protein, the S. This is a protein that attaches to human cells. Number 3, the main function of a virus is to infect cells with its RNA genetic material to produce more copies of the virus. And fourth, for our hypothesis, the most important feature of the virus is its lipid membrane, which, as we shall see later, is its Achilles heel. The typical strategy for fighting viruses is to target its proteins or its genetic material, the DNA or RNA, using drugs and vaccines. The science behind this is very sophisticated, and drugs and vaccines are designed to be very specific. And this approach is very expensive. However, one can also target the lipid membrane. And I do not know why people have not been targeting this. SARS-CoV-2 belongs to the beta coronavirus class, as we mentioned earlier. And the lipid membrane disintegration is a mechanism by which the beta-cov group of viruses can be effectively inactivated. And this is from a very recent article by Cascella, year 2020, so just a few weeks ago. So from the virus, let us now discuss the disease that it causes, COVID-19. The World Health Organization officially declared COVID-19 a pandemic on March 11. So that's almost just 2 months ago. Now the ACE2 receptors are present in a wide variety of human cells, revealing the potential risks of COVID-19. The spike proteins, S, on the surface of the coronavirus bind to cell receptors called ACE2 that are found in many places on the human body, as you see in the figure. SARS-CoV-2 appears to have evolved more effective spike proteins for binding to the ACE2 receptor. This may be the reason why this virus is able to cause more infection, affect more infection sites. While it is still considered as a respiratory disease, COVID-19 has become more than a respiratory disease, as we see in the news. It attacks a lot of other cells, other organs. It has also been noted that COVID-19 is most harmful to individuals who have comorbidity preconditions. And one major precondition is obesity. The data show higher risks for obese patients. So as you can see, for obese versus non-obese patients in Seattle, more obese patients required ventilation, and there were more deaths for the obese. In China, comparing obese versus overweight, 142% higher risk of developing pneumonia versus just the overweight. So obesity causes respiratory dysfunction, comorbidities such as heart disease, diabetes, and kidney disease, and numerous metabolic disorders such as hypertension, dyslipidemia. Individuals with these health issues tend to suffer severe cases of COVID-19. There's a clear link between diet and lifestyle and obesity. Despite their high socioeconomic status, the United Kingdom and the USA are suffering significantly higher mortality rates due to their high incidence of obesity. On the other hand, South Korea, which is likewise advanced, has a low mortality rate because of its low prevalence of obesity. Now let's talk about hand washing. Of course, we're all told to wash our hands and sing happy birthday twice. What is the science behind hand washing? Well, the viral membrane is made up of a lipid bilayer, which is an orderly arrangement of fat molecules. And soap is able to disrupt the lipid membrane. As you can see on this slide, you have the lipid bilayer structure in the middle, and when you put soap, which are surfactants, the soap disrupts the lipid bilayer. So this is the basic mechanism by which surfactants can disrupt the lipid bilayer. And so we're told to do frequent hand washing with soap to kill the coronavirus. So by the time you've finished singing happy birthday twice, the soap molecules would have destroyed the lipid membrane of the virus, effectively killing the virus. So now let's talk about coconut oil. First, some quick facts about coconut oil. The coconut has been consumed by people in the tropics for millennia. It is a basis for many of today's popular culinary dishes. Of course, in the Philippines, we have gata, you have curry, which is a very popular dish. The Pacific Islands would not have been inhabited if there were no coconuts. Coconut meat contains from 25% to 35% coconut oil. So if you squeeze the coconut meat, you get the coconut oil. Virgin coconut oil, or VCO, is obtained directly from fresh coconut meat without chemical processing. So you squeeze the VCO out of the fresh coconut meat. And VCO is what is called GRAS, that's generally recognized as safe. VCO has a long tradition of medicinal use and is considered as a functional food. Objections to coconut oil come from the West, where coconut oil is hardly consumed. And there is no valid evidence that coconut oil causes heart disease, but that is subject for another topic for another lecture. So the question is, how does coconut oil become activated? Trilaurin, the molecule, sorry for all the molecules in this slide. Trilaurin is what is known as a triglyceride, represent a typical coconut molecule. It is not active by itself and must be acted on by enzymes called lipase. The lipase enzyme is present in many parts of the body. So it's in your saliva, it's on your skin, in the digestive system, the liver, blood vessels, and other cells. Thus, anywhere in the body that trilaurin goes, lipase is there to activate it. As you can see in the figure, trilaurin will be acted on by lipase. You get this intermediate product plus lauric acid, and then more lipase will convert it to monolaurin, and then plus another molecule of lauric acid, until finally you just get glycerol plus another molecule of lauric acid. So from one molecule of trilaurin, you can, in theory, get 3 lauric acids, and you can get monolaurin along the way. Coconut oil becomes antibacterial and antiviral after hydrolysis with the lipase enzyme. The antibacterial and antiviral compounds include, in this figure, monolaurin and lauric acid, as well as other compounds from coconut oil called monocaprin and capric acid. Lauric acid makes up from 45 to 53% of the fatty acids in coconut oil. So there's quite a lot of lauric acid in coconut oil. Now, I will discuss here 2 mechanisms that are proposed by which coconut oil acts on the virus. The first one is that coconut oil, or the compounds rather from coconut oil, can disintegrate the viral membrane. And second, it can inhibit virus maturation inside the cell. So the first reaction, the first mechanism acts on the virus outside, while the second mechanism acts on the virus inside the cell. So we will discuss each one briefly. In this study by Holzer and Kabara, monolaurin reduced infectivity of 14 human RNA and DNA enveloped viruses in a cell culture by greater than 99%. And monolaurin acted by disintegrating the virus envelope. So here you see 3 photographs. A is the control. B is a treatment with a certain solution with monolaurin, and C is another solution with monolaurin. And as you can see, the virus gets disintegrated by monolaurin. In test tube experiments, monolaurin reduced the infectivity of herpes simplex type 1 virus in a dose-dependent manner. In other words, the more monolaurin you put in, the more of the virus you make ineffective. So high monolaurin concentration resulted in low viral infectivity. So this is a, again, this is on envelope viruses, envelope RNA and DNA viruses. In another paper, Thormar reported that medium chain fatty acids in particular lauric acid and capric acid, were active against 3 envelope viruses. So those 3 envelope viruses were those vesicular stomatitis virus, herpes simplex virus, and the Visna virus. The monoglycerides were also antiviral. Antiviral fatty acids were found to destroy the viral envelope, causing leakage and disintegration of the viral envelope. So one might say that coconut oil or compounds from coconut oil and hand washing share a common mechanism. Of course, you won't drink soap, but you can drink coconut oil. And the mechanism is disintegration of the lipid membrane. So as earlier noted, lipid membrane disintegration is the mechanism by which a beta coronavirus group can be effectively inactivated. So if you take in coconut oil, you ingest it, you get compounds from coconut oil inside the body, and this attacks the virus membrane. Similarly, hand washing, soap kills the virus by destroying also the lipid membrane. So, well, I found this cartoon from the Viber group, and this baby says, this is really weird and fishy. There's no vaccine for a virus which can be killed by soap. Well, they weren't thinking of coconut oil. So this is a curious question which I downloaded from social media, but it's quite relevant to what we're talking about. So now let's go to the second mechanism. How does coconut oil, or compounds rather from coconut oil, inhibit virus maturation? It's just to note that this mechanism happens inside the cell. So the virus has already entered the cell, and the question is, can compounds from coconut oil do anything about it? So in this article by Hornum, entitled Lauric Acid Inhibits the Maturation of Vesicular Stomatitis Virus, from this graph, it shows that the influence of fatty acid chain length and replication of this virus. Lauric acid is the most active fatty acid. And just note that the y-axis is a log scale. So C12 is the highest, and next comes C16. Between C12 and C16 is about 100 times. So lauric acid is at least 100 times more active than C16, which is palmitic acid in this case. In this next study by Bartolata, effect of fatty acids on arenavirus replication, inhibition of virus production by lauric acid, it shows from the electron microscope slides, vira cells, which are cells which are used for testing, were infected with this Junin virus over 24 hours in the absence or presence of lauric acid. So at 0 hours, they looked alike. After 24 hours, the control was, it showed proliferation of the virus, while with lauric acid, there was a smaller amount of the virus. So the proposed mechanism is that lauric acid interfered with the expression and assembly of the viral proteins, resulting in inhibition of virus replication. In other words, lauric acid decreased the infection or the replication of the virus inside the cell. So those are the two main mechanisms. The first mechanism, again, is that compounds from coconut oil disintegrates the viral membrane. Lauric acid and monolaurin, which are formed upon ingestion of coconut oil, and this is sodium lauryl sulfate, which we did not discuss, kill viruses by disintegration of the viral membrane. So that's mechanism one. Mechanism two is that lauric acid can inhibit virus maturation in a dose-dependent and reversible manner. What mechanism two implies is that you should have a steady concentration of lauric acid inside your system, meaning you should consume VCO regularly throughout the day, I guess. Now, I showed this slide earlier where the ACE2 receptors are present in a wide variety of human cells, revealing the potential risk of COVID-19. So where you have the ACE2 receptors, that's where the coronavirus can attach itself and attack the cells there. So what is the implication for coconut oil? Well, VCO can be taken safely, actually in a number of ways, and this can target the organs where the ACE2 receptors are present. So of course, the most common way of ingesting coconut oil is oral, so you can drink it. So if you drink it, then it goes, into your mouth and the bronchioles, into your stomach, and it also goes into the bloodstream. But you can also gargle coconut oil. So if you think that you've been exposed to, or you want to clean out your mouth or your throat rather, you can gargle VCO. You can practice oil pulling, which is an ancient, actually Ayurvedic tradition, where you swish VCO in your mouth for about 10 minutes, and then you can spit out the VCO. You can also apply VCO through nasal spray, and actually you can also apply VCO as eye drops. On that note, it was recently noted that the coronavirus can also enter through the eyes. So that's a useful piece of information. So this is the closing paragraph of that paper that we sent out on January 31. Given the considerable scientific evidence for the antiviral activity of coconut oil, lauric acid and its derivatives, and their general safety, and the absence of a cure for 2019 nCoV, we urge that clinical studies be conducted among patients who have been infected with this virus. This treatment is affordable and virtually risk-free because coconut is non-toxic and harmless. The potential benefits are enormous. However, so the presentation is basically given evidence that coconut oil is antiviral when you take it. However, what we now have to determine is how effective it is against this virus itself and curing the disease, COVID-19, as therapy or as prophylaxis. And in particular, what the best optimum dosage is and what the most effective modes of intake are. So the bottom line here is that we know that coconut oil is antiviral, but what we have to establish is how effective it is against this particular virus and how much coconut oil one should take. I would just like to introduce the members of our research group who participated in the in vitro study on the efficacy of lauric acid and its derivatives against COVID-19 virus. This project was funded by the Philippine Council for Health Research and Development, so we're very thankful for them for that. And the project is ongoing. The tests are being done at Singapore, at Duke NUS Medical School. So let's go to the last section is, so how do we survive COVID-19? It is important to realize that COVID-19 is a global pandemic. So it affects almost all countries in different ways. And so the solutions should be affordable and appropriate to all of these countries. So of course, we're aware of what's happening in New York City, but they have the hospitals and technology to handle the COVID-19. We have an outbreak in Brazil, Rio de Janeiro, they have their favelas. Europe is coming out of the COVID-19 pandemic, but it's also affecting Zimbabwe, India, and of course the Philippines. Basically, the approach here is that we should have a range of options, and there's really no one-size-fits-all solution for COVID-19. What they've been doing is that they've been repurposing drugs and vaccines. So digging into the medicine cabinet and looking for drugs that they can use. So there's quite a list of existing drugs which they are repurposing. You have chloroquine, hydroxychloroquine, remdesivir, sildenafil, which actually is the name for Viagra. You have an antiviral for influenza, and anti-HIV drugs, and other antibody treatments, as well as a vaccine. This is a tuberculosis vaccine that they're trying to test out for COVID-19. Now let's look at remdesivir. There you have the structure from remdesivir, and it's actually a very complex structure. On the right, you can see the synthetic route, which was patented by Gilead Sciences. It's a very sophisticated synthesis. Remdesivir was originally developed for Ebola and is being proposed for COVID-19. It decreased the hospital recovery time from 15 days to 11 days. So it's not really a cure, but it lessens the effect of COVID-19. Its manufacturer, Gilead, says that it may take 6 to 8 months to optimize the chemical synthesis process, and the cost is still undetermined. So this is likely to be an expensive drug. To survive COVID-19, we need appropriate solutions for the bottom of the pyramid. We have the ironic situation of obesity, where there is plenty, as well as malnutrition, where there is deprivation. And so the authors of this paper are suggesting that we really should build diverse food systems for post-COVID-19 world. To survive COVID-19, we must respect nature. One of the consequences of human encroachment on nature is the increased risk of emerging infectious diseases of animal origin. And as you can see, the Philippines is one of the countries which is relatively high risk of zoonotic, that's animal origin, emerging infectious diseases. And risk factors include having tropical forests, and then of course, invading the tropical forest, mammalian species richness, so the virus would jump from mammals to humans more easily, changes in land use, as well as population. Now, the frequency of zoonotic diseases increased dramatically after World War II, as you can see in this plot. Of course, after World War II, the global economy started a big expansion, and it expanded into nature. Since the year 2000, there have been 7 zoonotic viral outbreaks in humans. So the question is, can human society survive another COVID pandemic? In surviving COVID-19, we should keep our focus on the Sustainable Development Goals. The SDGs provide specific targets that we should meet. COVID-19 has simply brought our failures into sharper focus. In particular here, we can focus on the first 3 of the SDGs, no poverty, zero hunger, and good health and well-being. Our weakness in these 3 areas was really brought out by COVID-19. So regardless of whether we do vaccines or drugs and whether they will work or not, there's a range of solutions that we can adopt. Of course, there's the behavioral. We talk about physical distancing, wearing face masks, frequent hand washing, and disinfection. We can work on antibodies our own antibodies, and then if you can donate that, then you have convalescent serum. Monoclonal antibodies are being developed as well as vaccines, but they're not with us yet. Therapeutics, we have repurposed drugs, and some of them are still on the way to being validated. There's been a lot of talk about traditional medicine, Ayurveda, and traditional Chinese medicine, and of course, VCO. The last two are already available with us. And then, of course, we have to strengthen our immune system, take vitamins, especially vitamin C and D, zinc and selenium, improve our diet and nutrition, avoid all the obesity and comorbidities, improve our lifestyle, exercise, do traditional medicine, and as well as VCO. So the traditional medicine, VCO, can also strengthen the immune system. And of course, alongside that, we should still do the diagnostics and testing, contact tracing, using IT, information technology, epidemiology, computer modeling, and quarantine, and look at One Health. By One Health, we mean improving human health as well as environmental health. Now, to survive COVID-19, and this is the, I guess, the pitch for coconuts, is that we should look at coconut and see how it can improve our situation during and after COVID-19. Coconuts support farmers, so that's good for poverty. Coconut trees are environmentally friendly. Coconuts can be intercropped with other crops, so it's not monocrop. Coconuts can be directly consumed as nourishing food. They can be processed into hundreds of products, oleochemicals, industrial products. So truly, coconut tree is the tree of life. The figure that you see, which you really can't read, is just the throughput of how the coconut can be processed into various number of products. So in closing, let's go back to the theme of this webinar, which is Acts of Magis, Ateneans at the forefront of a pandemic. I would like to pose the question, with the hope that we will survive COVID-19, what next? We should start to correct all of the errors, excesses, and omissions that we have committed and improve everything for all people and for nature. These will truly be acts of Magis. So with that, I thank you for your attention, and I hope this webinar was useful for you. Thank you.
Thank you very much, Dr. Toby. From a layman's perspective, that was actually very, very helpful. No, I had no idea of how much good VCO can really do, no, for us. To our audience, no, we gathered some questions, all right, that we'd like to direct to Dr. Toby right now, no, just to further enlighten us about his presentations. No? But one question actually that I'd like to address to you immediately was, where did you get your shirt?
Oh, this. It's a coconut shirt.
Yes.
Actually, I forgot where I get it. I forgot where I get it. I think I was just shopping and I said, oh, this is a nice shirt. I should buy this. But maybe you can buy it in when you shopping again. You can look around for it.
Yes, no, but really the advocacy is clear, no, in not just in Dr. Toby's work, but even in his fashion sense, so to speak. No, but let's jump to some of the questions that we were able to gather. You mentioned that the question is, I'll read it now, that there have been clinical trials that have already started using VCO against COVID-19. No? And I think there's some literature out there already. You know, can you tell us a little more about these clinical trials?
Well, I can share with you some of the information about the trials that we're having in the Philippines.
Okay.
PCHRD is currently funding a feeding study on PUMs in Region 4. This is led by the Food and Nutrition Research Institute. So they are doing this feeding study to last for about 4 to 6 weeks on PUMs. And so you have a control group and a treatment group, and they give the treatment group VCO. And of course, the control group will not get it. So that is one study that started about 2 weeks ago. There's still another study in preparation, and that would be done in PGH, also to be funded by PCHRD.
I see.
We're trying to organize studies done internationally. Of course, coconut is a international product, and it would be nice if we get results from clinical studies all over the world, not just from the Philippines. So since I'm a member of the board of the advisory group of the International Coconut Community, we are trying to talk to other countries to see whether they can also launch their own clinical studies.
Okay. And then, Dr. B, does consuming coconut oil against COVID-19 per se need to be approved by FDA, or can I, as a normal citizen, choose to buy my VCO and then take it? No.
Oh yes, of course. VCO is a functional food. You can buy it from the supermarket or
Yes.
drugstore. You don't need a any doctor's permission to.
Prescription, yeah.
So I think, of course, but if you want to make it sort of official and scientific, then you do a clinical study. But in fact, there are many people who started taking it, and it should be treated as anecdotal reports. So you see them on Facebook. Actually, quite a number in Indonesia. They did Facebook posts about their experiences with VCO. So individuals have been taking VCO because it's cheap and it's safe. Perhaps the worst thing you would suffer is upset stomach if you're not used to taking VCO. But otherwise, there's really no ill effects.
There are no adverse effects.
Yes.
Yes. Now, Doc, I think you mentioned this during the first half of your presentation, but considering the two possible antiviral mechanisms of coconut oil, so is it pointing to the fact that coconut oil can be both prophylactic, meaning preventive, and therapeutic? Is
Yes.
that where it's
Yes.
pointing
Yes.
to?
Yes. In fact, it can be both. The difference would be the dosage. So of course, if you already have the virus inside you, so you got, and then you want a good supply of the compounds to attack the virus. So you take more VCO than if you were healthy. That's actually the advantage of VCO, is that the dosage is actually quite variable. There are people who just take 3 tablespoons a day. The others who take more, and really no serious side effects.
Okay. Actually, it's good you mentioned that. The next question from our guests was about how much coconut oil should we consume, to produce effective antiviral components. But as you mentioned, there's a bit of arbitrariness to it.
Yes. Actually, the 3 tablespoons a day is sort of came from tradition.
Okay.
20 years ago, they calculated how much coconut oil they could be eating kata 3 times a day, and they came up with about 3 tablespoons. So that was how the spoons came about. So sort of the standard prophylactic recommendation is 3 tablespoons a day. You can have 1 tablespoon after every meal.
After every meal.
Yes.
Does it matter Doc Toby, if you use the VCO, the quantity, let's say tablespoons per day, but I use 2 of the 3 tablespoons to mix it with other food.
Oh, yeah.
Instead of raw.
No, in fact, that's the advantage of VCO is that you can take it with meals, you can take it, or you can take it after meals. Some
Mm.
before meals. So it's really a functional food. So
Okay.
eat it like a food.
All right. Um, and as you mentioned, uh, either way, even if let's say there was no COVID-19 for us to study right now, taking VCO has a lot of health benefits.
Oh yes, well I've been taking VCO for what? So
Mm,
yeah, I've been taking 3 tablespoons of VCO
per a day.
a day, 2000, 2002. Yeah, yes.
And that's maybe where the glow in your skin comes from. No?
Well,
And
I,
then, sir, maybe just as a closing question, if proven effective, no, if again we were doing all the clinical trials right now, uh, what might be the challenges on the coconut industry? All right, face and those who are advocating coconut oil or VCO.
well, of course, the coconut industry is a different, set of challenges. Uh,
Hmm.
in the Philippines, of course, coconuts almost all over the world are really farmers' products. The
Yes.
trees are farmers. It's different. It's different for. It's not agro-industrial, as in, for example, palm oil is an agro-industry. The farmers, for coconuts, the farmers sort of they live on the land and they grow the coconuts. They sell some of the coconuts and then they can consume some of the coconuts. So the
Hmm.
economics of coconuts and its history are it's quite different. Culture is also quite different. So the approach coconut really needs it's a social approach. It's not well, it's not a simple problem, but the potentials are there because there are a lot of products, and so
Hmm.
challenge not just to the Philippine Coconut Authority, but it's really a challenge to the entire country how we can really, you know get coconuts together and grow it for the benefit of the farmers as well as for the entire society.
Yes. Now, Doc Toby, in case we have audience members who are interested to know more about your work with VCO, how can, or if they might have more questions, how can they get in touch with you and your team?
Oh, sure. Well, of course, they can get in touch by email. So email. Um, yeah, you can. So some of the papers are available. I think Dr. De Las Peñas will be posting my papers online.
Okay.
So yes,
Okay.
I
So,
welcome people. Yes.
all right. Any closing messages for our audience?
Well, I guess my closing message is maybe the first thing is that um, I've actually been studying coconuts for quite a long time, about 15, 18 years. And uh, when COVID-19 came, I really just reviewed what's available on, on coconuts. And I was really uh, surprised by how much information is there for its potential, and it really brings out the fact that there's a lot of undiscovered potential in coconuts, and I think we should really try to develop it more, and I think it will benefit, of course, coconut farmers as well as the entire country.
Okay, thank you very much, Doc Toby. I'm sure I wish no you could hear the. I'm sure the audience are very happy, very pleased, very hopeful with your study, and they'd be giving you a round of applause. But the audio, of course, has limitations, so we'll just give you hearts,
Okay, thank
or
you.
or they could actually look like coconut leaves, spreading outward. Whatever would make you happy. But
Yes.
thank you very much, Doc
Okay, thank you
Toby.
also. Yeah, thank you to everyone for putting this together, and I hope you find it worthwhile and go coconuts.
Yes, we'll definitely go coconuts. And in line with that, no, this is just the second research that we have shared with you in Acts of Magis, Ateneans at the forefront of a pandemic, please do join us in our next two episodes, and perhaps we can even go beyond those. No? Again, we'd like to thank all the organizers. In particular, we'd like to thank the University Research Council and the Ateneo Research Institute of Science and Engineering for putting all of these together. We'd also like to thank all the people who are helping us at the background, our IT people, to bring this to the world, to the Philippines, and bring hope. So thank you very much. Again, this is Chris Castillo, and this is Acts of Magis, Ateneans at the forefront of a pandemic.
Thank you.